Hello there. So in this video session, we are trying to find out the centroid for a wire which is going to be bent in a circular form. In the previous video sessions, we have seen the wire bent in a curved shape or in the straight line. Because the centroid finding is one of the important aspects for the design of any component. In the engineering sector, it is going to be the primemost thing, so that the uniform balancing of the forces will going to be taking place. Now we can see how to find out. So in this case, locate the centroid of a uniform wire bent in the form of a semicircular arc of a radius r. So as we know that, so he has given a uniform wire. So what is the uniform wire? The uniform wire is going to be representing it has the density is going to be the constant, and in terms of the geometrical properties, the area is going to be constant. We are going to be assuming. So then it is bent in the semicircle and it has a radius r, it is there. So that configuration I have drawn over here, so there we can see. So in this case, he has given this one is going to be your semicircular arc. That means the wire is bent in this shape. So now we are going to be trying to find out the different parameters and how we are going to be locating the center of this with respect to the x-axis and the y-axis. We are going to be finding the centroid for this bent wire. So in this one, he has given only the radius. So we need to find out the centroid. Already we have framed certain rules so that we need to follow. Then we are able to identify the centroid further with respect to x-axis as well as the y-axis. What I am going to do? First of all, I am going to be taking the coordinate system. Where we need to take the coordinate system? For my convenient, I am going to be taking at the middle of this semicircle. The first I am going to be taking in the y-axis in this direction. And similarly, x-axis I am going to be taking in this direction. So this is going to be your x-axis and this is going to be your y-axis we have taken, right? And next what I am going to do, I am going to be using this radius and I am going to be measuring this part. And from here to here, the distance is going to be, this point is going to be the origin, O I am going to be calling. So then in this case, the distance is going to be your radius. As we know, that's already has provided that wire was bent at a radius of r. So then what other parameters you require? So as you know, this is the total length he has given. L is going to be, we are assuming that the perimeter length is going to be L is going to be the total length. The total length, that may be in according to the units whatever he has provided. So then this is going to be the r and L is going to be the length of your semicircular wire. At the same time, we assumed that it is going to be a uniform cross section, uniform homogeneity. That means the density it is there. A is going to be the constant and the density also the constant. So when the density and the area is going to be constant, it is very clear that this is going to be one-dimensional body. What is this one? This is the one-dimensional body. In this case, what will happen? That area is going to be distributing along the length of the member. It means that one dimensions are going to be good enough. And it is going to be the density means it's the member, it has a homogeneity. So then how could you proceed this part? After identifying these kind of assumptions, we are going to go with we need to divide the given object into number of elements. So for the time being, I am going to be taking, this is going to be the element of this member. So like that, you can make it the number of divisions over there. Alright, so then what I am going to be connecting to the origin. Right, and the elemental, the length I am going to be taking here is going to be the dl is going to be your elemental length. The next, it is going to be making with respect to the horizontal axis, this is going to be a theta, and similarly this elemental strip is going to be making an angle of d theta. Right, so then we have taken, so then this is going to be the O, I am going to be calling this end is going to be the A, this is going to be the B. Right, so once we have taken the elemental strip and we have identified the angle of that displacement, that means what is the angle it is going to be, the position, and the dl is going to be your elemental length and theta is going to be making with respect to horizontal axis. That means the elemental strip is going to be making an angle theta. So then what are the things we need to do? As we know, by using the theorem of varignon, what is the formula we do have? And already we have derived that. That's going to be the total length. Suppose I am going to be taking with respect to the y-axis. So now I need to find out the centroid with respect to the y axis. Then I am going to be measuring from this direction. Suppose this is going to be your xc, this is going to be your yc. Alright, the centroid that I am going to got it. So that I am going to be writing L into xc, because I am going to be taking with respect to the y axis, that the centroid I am going to be taking the xc. So that is equal to, what is the formula? That's going to be the summation of the summation of the moments of the individual forces we need to take. That's going to be integral. What is the formula we do have? That's going to be, see what is the distance it is going to be located from this part. This is going to be the yc is going to be your centroid, suppose, and this is going to be distance is located, that's going to be the x. At the same time, the B point is going to be located at a distance of y. So then in this case, that's I am going to be multiplying, that's with the x into dl I am going to be taking. So that means the dl is going to be your elemental strip that is going to be located at a distance of x, right? So then we need to find out what is the x as well as the dl. How could you find out that dl is equal to? So for this one I am going to be taking the triangle OAB I am going to be taking. So in this case, triangle OAB is equal to, I am going to be taking OAB. So in this case, I need to find out what is the dl in terms of the radius as well as the theta, right? So that I am going to be taking tan theta is equal to, suppose this is going to be the O, this is the dl, this is the d theta, and next this is the r. So this is A as well as the B, right? Once it is going to be tan theta is equal to, what is the formula? dl by r I am going to be taking. The dl is equal to, so here is the not the theta, this is going to be the d theta, we have to take it. That's going to be r into d theta I am going to be considering, because tan d theta is going to be the very small. So now we got the dl is equal to r d theta. So if suppose I am going to be go for the integration, what I am going to, because it is existed between the 0 to pi. So this is the 0 angle to pi, that is the limits. The limits of this bend is equal to 0 to pi, it is there. Right? 0 to pi I am going to be substituting. This total length is going to be 0 to L, that's going to be integral 0 to pi r d theta. So once it is going to be dl, that is equal to, this parameter will become the L, right? So then that's L is equal to r into d theta. R is the constant, d theta will become the theta. Then if I am going to be substituting 0 and pi, then finally I am going to be getting pi r, I will get it, right? So that's going to be the pi r, I got it, that is equivalent to the your perimeter length. So from this one we have calculated, there we can see we have calculated the L as well as the dl. Now I am going to be substituting in this equation. So what I am going to be getting in this, from this part, L x c, I am getting the dl. Then how could you calculate the x? Because it is located at a distance of x from the reference of the y. Then how could you calculate? I am going to be taking, this is going to be the A, B, I am going to say the C. Suppose if I am going to be taking the triangle O, B, C. So then what is this part? So this is going to be, this is like this, because I have taken the projection of the point B over here. So this is going to be O, B, C. This is the x distance, this is the r distance, right? So we need to find out that part. So how could you find out this one? So then if I am going to be taking, this is the theta, right? So then cos theta is equal to x by r. We need to find out the x value. So then from this one, r is equal to, that's the r is equal to, sorry, x is equal to r cos theta. So that x is equal to r cos theta, that we got it. So this way we are going to be calculating the x value. So once we calculated the x value, L value and dl, at present I am going to be taking the L dl, I am going to be substituting this one. That's going to be x is equal to, because it is located 0 to pi distance. So then in this case x is equal to, what is that one? R cos theta we are going to be taking. And similarly dl is equal to r d theta we are going to be taking. So in this case the theta is going to be the variable. So then in this case 0 to pi we will get it. So from this one, how we are going to be, this r will become the r square. I am going to be taking out from the integral 0 to pi, then cos theta into d theta. So then once we are going to be integrate it, then what we have, that's going to be r square is equal to minus sin theta 0 to pi. These are the limits we have taken. Once we are going to be substituting the pi as well as the 0 in this equation, what the finally we are going to be seeing. And sorry, here the cos theta integral is going to be over the sin theta we are going to be getting. So once if I am going to be substituting the 0 and pi, so that equations we will getting L into xc, that is equal to r square, in this case sin pi minus sin 0. Right? In this case sin 0 is equal to the 0 and the sin pi is will become the cos 90 degrees, and then the cos 90 degrees is equal to 0. Then this total parameter will become the 0. So then xc is equal to 0 into r square is equal to 0 by L we are getting the finally xc I got it the 0 because it is located. Then what is the indication of the x is equal to c? This means the bent y is going to be symmetry with respect to the y axis. That's why x I got it the centroid for this object, xc is equal to 0. So that I am going to be writing xc is equal to 0. So now we need to find out the, with respect to the x-axis, we need to find out the centroid, what distance it is going to be located. So now the case is that this is going to be the x-axis, at what distance the total body centroid is going to be existed, that we need to find out. So then what is the formula we do have, that I am going to be taking, this is the yc distance it is there from your x-axis. So that I am going to be taking here, that's going to be L into yc, it is located, that is equal to the integral, the elemental areas we need to take it. Elemental areas means here, so from this part, what is the, it is going to be existed. So that means this is the y distance it is there, that's going to be y into dl, right? And the dl into y is going to be your, the first moment of inertia over here. So then we know the dl is equal to r d theta. Then how could you calculate the y value? Again we are going to be taking the triangle OAB. Suppose if I am going to be taking, this is going to be, sorry, not the triangle OAB. Now I am taking the OBC triangle, OBC triangle, it is making the theta. So then in this case we need to find out the y value in terms of r as well as the theta. So then that is equal to sin theta is equal to y by r. So then y is equal to r sin theta, that we need to take it. Right? So that I am going to be taking here, y is equal to r sin theta. So then we need to substitute in this equation. So what I am getting finally, L yc is equal to, y is equal to, what is the formula? R sin theta. dl is equal to r d theta. We got it. So further simplification, r is equal to d theta is the variable here, that's going to be 0 to pi, that's going to be sin theta, and d theta we will get it. If once you are going to be integrating the sin theta d theta, we will get that answer. So once if I am going to do the integration, r square, the sin theta is going to be minus cos theta 0 to pi. So once if I am going to be substituting 0 and pi in this equation, that's going to be LYC is equal to r square minus cos pi minus of minus cos 0. So in this case, the cos pi is equal to what we are going to be say, that's going to be sin 90 degrees. Sin 90 degrees is equal to 1, we will get it. So that means in the second quadrant, the sign will going to be the positive. So then cos 0 is equal to, we do have the 1. So from this one, we are calculating the cos pi and this one. So that I am going to be taking LYC, that is equal to r square 1 plus 1. Then LYC is equal to 2r square, I got it. So how we can make it the further simplification? So L I got in terms of pi into r. So this is also one equation we got it. From this one, we need to find out the YC in terms of the pi and r. So if I am going to be substituting in this equation, the YC is equal to 2r square by pi into r. right? So then r will going to be cancelled. Then finally yc is equal to 2r by pi. So that's yc is equal to 2r by pi. We got it, right? So this way we are going to be calculating your centroid with respect to the y-axis and the centroid with respect to the x-axis. And xc we got is the 0. It means that the body is going to be have the symmetry existed between the y-axis. And when we are getting the yc means it is not in the symmetry, but we got it, the value is the 2r by pi. This way we are going to be calculating the centroid for the semicircular wire bent.